The other thing that we need to be careful of when we're doing dividing polynomials is that when we're doing long division, we have to make sure that every single term is accounted for. So in this case, when I'm dividing by x squared plus 1, if you were to write that in standard form, it's missing an x term. So usually, the exponents go from highest to lowest in order. So if there's one missing, it's not there usually. So here, x squared plus 1 is missing the x term in the middle. So we have to account for that. So we're going to put in a 0x. So every term has to be there. So if we look at what is going inside of our division bar, we have 3x to the fourth. Then we have a negative 4x cubed. Then we have a 12x squared. Then we're missing the x term. It jumps right to 5. So we have to put in a 0x here, and then plus 5. So same process. Okay, we have an x squared, and we want a 3x to the fourth. So we need a 3x squared. We're going to multiply to all 3. So we're going to multiply to get 3x to the fourth. This is just going to give us a 0. And this will give us a 3x squared. So we'll subtract. 3x to the fourth minus 3x to the fourth is gone. Negative 4x cubed minus 0 is just a negative 4x cubed. 12x squared minus 3x squared is going to give me a 9x squared. And then I need to bring down my next term so that I have 3 on the bottom and 3 on the side. So same process now. We're going to look at the x squared on the left, and we need a negative 4x cubed. So that's going to be a negative 4x, and we're going to multiply. So that's going to give us a negative 4x cubed. This is going to give us a 0, and then this is going to give us a negative 4x. We subtract. Negative 4x cubes are gone. 9x squared minus 0 is just 9x squared. 0x minus a negative 4x becomes a positive 4x. And then we have to bring down the 5. Okay, so again, we have an x squared. We want a 9x squared. So we're going to put a plus 9. 9 times x squared is 9x squared. 9 times 0x is 0. 9 times 1 is 9. So when I subtract this, the 9x squareds are gone. 4x minus 0 is 4x. 5 minus 9 is negative 4. Now I have nothing left. So this is my remainder. So the way I write my remainder, whatever sign is in front of the first one, the first term, is the sign we put up top. So if it's a minus, we'll put a minus. If it's a positive, we'll put a positive. So it's plus, and then it's 4x minus 4 as the numerator. The denominator is then going to be x squared plus 1. So whatever we had on the outside is the denominator. Our remainder is the numerator. So then this would be my complete answer. So it didn't go unevenly, and there is a remainder. And instead of saying remainder, whatever, we're going to write it as a fraction. Another way that we can divide is through synthetic division. So what synthetic division is a shortcut kind of way to divide. You can only use synthetic division if you're dividing by a binomial that has a 1 in front of the x. So if this was 5x plus 2, you wouldn't use synthetic division for that. If it was x squared plus 2 or something, you wouldn't use synthetic division. So if it's x plus or minus a number, you can use synthetic division. The way that we set this up, so it's a little bit weird at first. We take the opposite sign of what we're dividing by. So x plus 2, so it's a positive 2, we're going to reverse the sign. So it's going to be a negative 2. And then we draw this weird upside down division bar. And then the coefficients of the polynomial go across the top. So in front of the x cubed, I have 1. In front of the x squared, I have a negative 14. In front of the x, I have a 51. And then my constant is a negative 54. So when you're doing synthetic division, you're not using the x's at all until the very end. Okay, so step 2 is to bring down the first coefficient. So the first coefficient is going to come down, whatever that is. So whether it's a 1 or it's any other number, that number comes down. Then step 3 says to multiply the coefficient by the divisor. So we're going to multiply these two together. So 1 times negative 2 is a negative 2. I put the answer here. Now instead of subtracting like we do with long division, we synthetically add. So negative 14 plus negative 2 is going to give me a negative 16. And then I'm going to repeat the step. So negative 16 times negative 2 on the outside gives me a positive 32. So my answers go on the inside. I add 51 and 32, and I get 83. 83 times negative 2 is going to give me a negative 166. And then I'm going to add negative 54 and negative 166 and get negative 220. And I'm going to balance that. So that's my remainder. So once we have all that out, we're going to write our answer by just dropping a degree. So we started off with x cubed. So my answer is going to start out as x squared. Since we're dividing it by an x, it's going to reduce everything by 1. These values here are the new coefficients. So that's a 1x squared minus a 16x plus 83. And then our remainder here is a negative 220. So we're going to say minus 220 over x plus 2. So this would be our answer for this. It takes some getting used to. It's a lot faster than long division. So let's try another example. Okay, so use synthetic division, and we're dividing x cubed minus 57x plus 56 by x minus 7. So first thing we have to do is to reverse the sign. So 7 goes on the outside. Then I have my weird division bar. Just like with long division, you have to take into account any terms that are missing. So in front of the x cubed, I have a 1. After x cubed would come x squared, but there's no x squared here, it's missing. So we're going to put in a 0. Then we have a negative 57, and then we have a positive 56. So we're going to bring down the 1. 1 times 7 is 7. 0 plus 7 is 7. 7 times 7 is 49. Negative 57 plus 49 is negative 8. Negative 8 times 7 is negative 56. Add them, we get 0 as our remainder. We're going to drop a degree, so I have x squared plus 7x minus 8 as my answer. Okay, so try another one. Okay, so if it doesn't ask you to specifically solve it with synthetic division, if you like long division, you can use long division every single time. Okay, you have to use long division if you don't have a binomial like this. So if you had x squared that you're dividing by, you have to use long division. So I'm going to reverse the sign. So negative 4 on the outside. Coefficients along the top. So a 1, a negative 7, a negative 7, and a 20. First number comes down. 1 times negative 4, negative 4. I'm going to add, I get negative 11. I'm going to multiply, I get 44. I'm going to add, I get 37. I'm going to multiply, I get negative 148. I'm going to add, I get negative 128. There's my remainder. Drop a degree, x squared minus 11x plus 37 minus 128 over x plus 4. Okay, so let's skip to another one. Okay, so here again, if you are missing terms, you have to fill them in. So we're going to put a negative 3 on the outside. In front of x to the third, I have 1. Then x squared, there is none. X, there is none, and then our constant. So we have to put in 2 zeros here. Bring down the first term. 1 times negative 3 is negative 3. I add it. I multiply it. I add it. I multiply it. I add it. Drop a degree. X squared minus 3x plus 9 plus 21 over x plus 3. Okay, an expression is a factor if there is no remainder during division. So if you do division and there's no remainder and it goes in evenly, that means that that number you divided by is a factor of that larger polynomial. So if we look at these examples, is x minus 5 a factor of 2x cubed plus 7x squared plus 2x plus 1? So in order to know if it's a factor, it's a yes or no answer. So we don't have to write out our polynomial solution as an actual polynomial expression. We just need to set it up and figure out if our remainder is 0 or not. So 5 on the outside, 2, 7, 2, 1. The 2 is going to come down. 10, 17. I'm going to multiply, I get 85. I'm going to add, I get 87. I'm going to multiply, I get 435. So when I add, I get 436. Because I have a remainder that's not 0, this is not a factor. So is it a factor? No. So 8 is going to go on the outside. 1, negative 5, negative 20, negative 32. We're going to bring the 1 down. 8. I'm going to add, I get 3. I'm going to multiply, I get 24. Add, I get 4. Multiply, I get 32. Add, I get 0. Since I have a 0, yes, this is a factor. So x minus 8 is a factor of that. Okay, so for this one, x plus 1/2, we're going to put negative 1/2 on the outside. 4, negative 12, and 9. 4 comes down. I multiply, and I get negative 2. I add it, I get negative 14. Negative 1/2 times negative 14 is a positive 7. I add, I get 16. No, it's not a factor since my remainder is not a 0.